So far, sine theta for you people, you know as opposite over hypotenuse. You know what? I better remind you of this because a bunch of people have been in and out of the class for the last little while. Theta is that angle. Blue theta is that angle. I'm going to name the gold one A. I'm going to name the blue one B, which makes this C, which makes this side little a, this side little b, and this side little c. Hey, Mr. Como, how's it going? So, this is what you have already done up until now. We are going to apply this into more real-life situations, okay? So starting from here, you should all be able to tell me the sine, cosine, and tangent of gold theta, and you should be able to tell me the sine, cosine, and tangent of blue theta. Now, you will notice there are no numbers here, so just use the letters that are given. Everybody go. Would anybody like to offer me the gold measurements right now? Jordy, please.
So theta equals shift cosine.
No. I want sine of theta. I don't want the value of theta. I want the value of the sine of theta. I want the ratio. And I've lost my, one moment, I've lost my highlighter. Okay, back here. There we go.
Myers, could you lock Mr. DeVries'
Lock Mr. DeVries' room. Yes, I can. While I am locking that, all of you should be writing these down. You go, guys. Do we have it? What is the ratio for sine of gold theta? Pardon me? A over C. Excellently done. What is the ratio for cosine theta? C over A? So, ka, toa. It is adjacent over, pardon me? B over C. Excellently done. And tangent of gold theta? A over B. Now, what is it on the blue side? What is blue theta? B over C. A over C and B over A. What are the only sides that change as I move around the triangle? The opposite, the adjacent, or the hypotenuses? Which are the ones that change? Opposite and adjacent change. Why?
Because
hypotenuse is always the... Can't say it's the slant, because if I draw it this way, that hypotenuse is not slanted. So what is it? Across from the right angle. And what's the proper word for across when we're doing trig? Opposite. Okay, so we're all cool to here, yes? All right, now, so I'm going to remind you right here of what I just reminded you of here. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, yes? Now, this golden triangle that I have right here, right? What does this look like? Looks like a graph, yeah? Which makes this line what? X, and this line what? Okay. If I take that golden triangle, and I will continue the color scheme for us, I could draw it right there, couldn't I? Everyone agrees? Okay. Now, this point right here, what do you know about that point right now? What do you know about it? Pardon me? No. Theta would be the angle. I'm just talking about that point right there. Take out the angle. That's my fault. What do you know about that point right there? It has a positive x value and a positive y value. Does everyone agree? Okay. What if I put that same line point, I come over here, what do you know about that green point? Negative x, y. What do I know about the dusty blue point? Negative x, negative y. And what do I know about the hot pink point? X, negative y. Excellently done, ladies and gentlemen. So, now, let's add that triangle back in. Now we have our golden triangle here, yes? Okay. What is this distance? What is the distance? You don't know, so what do we give it? What variable should we give it? We can give it any letter we want, but there's a letter that would make sense, wouldn't it? How far up did this line go? What amount? Positive y. How far did this go? Positive x. How could you use the math that you already know to tell me the length of this hypotenuse? How does that tell me the length of the hypotenuse, Jordy? Give Jordy one more shot, RJ.
Well, we could do Pythagoras.
Okay, so what would then be this distance?
I don't know what variable to give it, but then it would equal...
But you do know what variable to give it because you said this is x. How do you do Pythagoras?
Well, x squared plus y squared equals...
Right. Equals c squared. So what do we have to do to x squared and y squared, Animal, to get the actual value here? Square root. So this is the root of x squared plus y squared. Does everyone agree? All right. Now, I'm going to put gold theta right there. What is the sign of gold theta? Yes, sine of gold theta. Sorry, ladies and gentlemen. Sine of theta is y over the root of x squared plus y squared. Yes? Right? Sine is also O over H, isn't it? So if I gave you an xy value, can you do sine without drawing a triangle? How? If I gave you an xy value, so now that we've done it theoretically, somebody give me some numbers for there. What could I put there? 3, 4? Okay. So that is 3, 4. Right? Okay. So now, you know this is the sign, yes? So you know this to be 3, because x equals 3, y to be 4. Now you automatically know what this is. What is it? 5, because we've memorized 3, 4, 5 triangles, yeah? But even if we hadn't memorized 3, 4, 5 triangles, we would take 3 and square it to get, take 4 and square it to get, add them to get 25 and take a square root. Everybody agree? So now, sine is opposite over hypotenuse. But if I put it on the grid, I know it's y over x squared plus y squared. Everybody with me? Okay, well, what then is cosine? We know it to be a over h. What is it if I put it on the grid? Excellently done. And what is tan?
Tan would be y over x.
Y over x. Everybody cool? Now, what do you notice about all three of these values if you compare it to this side? What is this now? Negative x. What is this now? Which is it, Riley? Positive y. And what is this? This is tricky. Root negative x squared. But wait a minute. What happens when I square a negative? Okay. So we're going to write it that way, plus y squared. So even though this has become negative, will this distance, the hypotenuse, ever be negative? Why not? Every time you root? No, you're right, Abner. Just change the word.
Because if you use negatives, like if you use negative, then it's never going to stay negative. It's going to
Right, because when you square a negative, there you go. Everybody cool? So now over here, you're smart young people, what is the sign of green theta?
The sign?
Mm-hmm.
Would it be y over root negative x squared plus y squared?
Right, but negative x squared is what? Just x squared.
Plus y squared.
Okay, what is the cosine of green theta?
It would be negative x over negative x squared plus y squared.
And what is the tan of green theta? Y over negative x. Now look at this carefully. In the gold theta, what did you notice about all our values? They're all positive. What happened for green theta? The x's are negative, so anything involving an x is what? Going to be a negative value, right? What's the only thing that doesn't involve an x here? Sine, cos, or tan. So over here, all ratios are what? Positive. What's positive here? Sine is positive. You're smart young people. You figure out blue theta. What are its sine, cosine, and tangent going to be? Bye, Mr. Como. Have a good weekend. You've seen it now done twice. I did the whole first one. We went sharesies on the green one. You try the blue one. What's the first one going to be?
negative y over root x to x
Right.
squared plus y.
Right. So let's call that the hypotenuse, right? What's cos going to be?
Negative x and over hypotenuse.
And what's tangent going to be?
Negative y over negative x.
What? Y over x. Why is it y over x? Because both negatives make a positive. So what is the only positive guy down here? Tan theta. Or tan is positive. Now, without writing anything down, what do you know is going to happen with pink theta?
Second way of theta, I think cosine is going to be positive.
We know cos is positive, right?
Yeah.
And we know that what is sine?
Negative.
Negative y over h. What is cosine?
Cosine is x over e.
And what is tan? Everybody cool? And now we are not restricted to doing our trigonometry from 0 to 90, are we? Everybody cool? All right. Now you're going to learn some new words. An angle is in standard position. It's bold and it's capitalized. Is it a term you need to know? Yes, and then your teacher highlighted it for you, making it doubly important. An angle is in standard position if the initial arm. Have you seen that word before? Have I used it?
Initial?
No, that term, initial arm. Have I used it? What?
You used it. I've heard you say it. I don't remember.
Okay, what does initial mean?
First.
First, what would an arm of an angle be?
The long.
One of the lines, yes? Okay. The initial arm, which I'm going to highlight in yellow, the initial arm is on the x-axis. Now, don't write down what I'm about to do. Okay, just watch and think. I'm going to highlight some angles. You just think yes or no. All right? If the angle I highlight has its initial arm on the x-axis, I forgot one part, on the positive x-axis, all right, is that angle in standard position? Just yes or no in your head. Don't say it out loud. Everybody have an answer? Yes or no? That blue angle is in standard position. No, of course not. Why? Neither arm is on the positive x-axis. All right? Okay. What about this blue one? In your head, yes or no? I don't want to see any head shakes or anything. Yes or no? No. Why? Because it's on the negative x-axis. Eh? Okay. What if I told you I mean the pink angle? Pink theta right there. Do you think that is in standard position? Yes or no? Okay, and why do you think that? Pardon me? One arm is on the x-axis. All right, everybody cool? Keep that in your head. We're going to come back to that. All right. The other ray forming the angle. So remember, an angle needs two rays, right? Or arms. One of them is the initial arm. The other ray is the terminal arm. And I'm going to highlight that in blue. Now, the terminal arm, if that is the initial arm of all four of these thetas, right? Then how many terminal arms must I draw here? How many terminal arms must I draw here if that is the initial arm? How many angles have I formed here? I've formed only two angles. What symbol means an angle? How many thetas do you see? So, I see 4 thetas myself. So how many terminal arms must I draw? 4. There, 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 and there. Agreed?
Agreed.
Now, if initial means first, what does terminal mean? The end, right? If you're terminally ill, you're ill till the end. If you take a bus to a bus terminal, that's where it ends. You see the word terminate in terminal, right? So, if this is my initial arm, and this is where the angle ends, that made our gold theta, yes? And our gold theta must be between what two values? What are the two limits of gold theta in degrees? 0 and 90. Agreed? Okay. If this is the starting arm, right? This is where I start from, then, and this is my first angle, then logically I must go to here for my second angle, yes?
Yeah.
Which means this is not theta, is it? This is theta. And what must its limits be? 180 between what and what? Can be, no, because I've gone past 90, right? So any line out here can't be less than 90. What must it be? 90 to 180, agreed? Okay. What then is blue theta? What are its limits? 180 to... Well, if this is 90 and this is 180, what is this obviously? 270. And what then is pink theta? 270 to 360. Excellent. All right. So, counterclockwise rotation. In Britain, it's anti-clockwise rotation. Counterclockwise rotation means we start at the positive x-axis. If we rotate counterclockwise, to the terminal arm, we get a positive angle. So, the way I have drawn all three of these, actually 4 of these thetas, they are all going to be positive because we started here and went counterclockwise. Everybody cool? The first one, gold theta, has to be between 0 and 90. Positive. Green has to be between 90 and 180. Positive. Everybody cool? All right. You're smart kids. If counterclockwise is positive, what's clockwise? Clockwise gives us negative values. Is everybody good? Now you should have a bunch of blank space down here now, yes? Give me a coordinate grid. Everybody cool? Everybody cool? Okay. I'm going to draw that initial arm. What color did I do the initial arm? Yellow, yes? To that terminal arm. Everybody cool? And I'm going to tell you that that point right there is, let's go with 6, -8. Everybody good? Okay. No, actually, I don't want to do that. If I go this way, what is that value? Positive or negative? Positive. And what's the least it could be? Could be 270. Agreed? Did we go past 270? Right. Did we get halfway between the next two? Does it look like it? You want to say it's halfway? That's cool with me. Okay, so what is this value then if we say it is exactly halfway? How far is it to here? How far is it? Okay, we'll do this slower. How far is it to there? Then there. Then there. And that's halfway. So what is it? 305. Positive. What is it that way? Is 305 right? What's half of 90? How far is it to here? How far is that? How far is that? How far is that? So how far is that? 315. There we go. And then what is the red value? Negative 45, because we went that way. Is everybody cool? This angle has two values. It's 315, but it's also negative 45. Everybody cool? That is called coterminal, because they share the same terminal arm. Everybody okay? All right, let's do another one. Don't write this down, just use your brain, because that should be all you needed. I'm going to draw a red line right there. Nah, that's no good. I'm going to draw a red line right there. What would you say that is? Is it past halfway? Is it 90? So give me a value that could have. 80? Okay. Positive or negative 80? Positive 80. Excellent. Negative what? What? Negative 280. Why? 360 reversed. Everybody cool? Okay. Now I'm going to do something really weird. We all understand coterminal, yeah? Okay, watch this. I'm going to put a purple line on here. Everybody cool? And the answer that I seek is not either of the two answers you've already given me. Everybody okay? What's the purple angle? And you cannot say either of the two answers you just gave me. Just want to see if anyone can figure it out. What? Positive 280. Okay, that if it were positive 280, Jordy, I would start here, yes? 90, 180, 270, 280. Nope. I know you people don't like not knowing the answer, and you won't say it for fear of being wrong. But you don't know this yet. I haven't taught it to you. You have to use your brains. And you may have to take a risk. Pardon me? Negative 80? That would be right down here. Negative 280. That was one of the ones we just said. Negative 280 would be starting here and going clockwise, right? 90, 180, 270, and 10 more. Negative 280. We've already said that one. Pardon me? 440. Why?
Because it goes right
Because there's 80, and then I do another 360. We've all played enough Shaun White 1080 snowboarding to know how many degrees are in a circle, yes? I know, all the boys are going, yeah, that game was awesome. What's the next one that's coterminal there? If this one is 440, what is this dark blue one? $800. What is this orange one? $1660? $1660? Right, 1,160. Why? Because what am I adding each time I go around the circle? 360. Yay, all right. Okay, turn the page over. Sketch all of these angles. You do not have a protractor, so what am I looking for? I'm only looking for it to be in the right quadrant, yes? Okay, and appropriate, right? If it says 2 degrees, you wouldn't draw it there, right? Because 2 degrees would be a very little bit. You've got to draw 6 lines. It should take about a minute. Go. Mayor, you just had your hand up. What do you need? No, you will never need a protractor. Remember, I want it in standard position, so that tells you where to start. All right, what quadrant will A be in? Top right. That is the first quadrant. I forgot to remind you of that. That is 1. That is 2. You may want to put that on the big quadrant on the front. That is 3. And that is 4. So it's going to be in the first quadrant, yes? Is it going to be above or below halfway? Below, for lack of a better word. So it would be somewhere over there, yes? Everybody happy with that? Where's the second one going to be? In quadrant 2. Where? Below half, half, or above half? 135? Half, exactly. Because how far is this? 90, and I need to go to 135. So this is 45 more. Right? Where's C going to be? Quadrant 3. Past half?
No.
Because this far is 180, then how much further do I have to go? I got to go further than half, don't I? Because I need to go how much further? 65 more, right? I know adding is hard sometimes. 65 is going to be where? Thank you. 285 is going to be where? Fourth quadrant, very close to the y-axis or very close to the x-axis? Y-axis. Because that's 270 and I only needed 15 more. 115? Closer to the y-axis or closer to the x-axis? The y-axis. Can everybody draw an angle in standard position? Right? We just count. Go to the 90, the 180, or the 270 and add, subtract, whatever you need. Everybody good? All right. If you have an angle in standard position, for example, angle B is in standard position, which means we started counting here and went to there, yes? That gives me another angle, doesn't it? It gives me this angle here, right? All right. That is the reference angle. The reference angle is between the terminal arm and the nearest, please underline or highlight nearest x-axis. Everybody cool? All right. So in this first one, somebody give me an angle that would have the coterminal arm in the first quadrant. 60? No problem. Let's draw it. Riley May has given us 60 degrees. There's the initial arm. And the terminal arm closer to the y-axis or closer to the x-axis? Closer to the y-axis because it's 60. Agreed? Okay. What is the nearest x-axis to this terminal arm? Is it yellow or blue? Blue. Okay. So that means that if my angle is here, this is theta, isn't it? But it's also, and I'll change shades of red to a pink, it is also theta r, reference angle. Everybody cool? In the first quadrant, it doesn't make any difference. They're the same thing. But you'll see what happens in the second quadrant. Now somebody give me an angle that would be in the second quadrant. 120. 120 will start there, and we will count clockwise or counterclockwise from here. Counterclockwise. And when I stop, will I be closer to the x-axis or the y-axis? I will be closer to the y-axis because halfway would be 135, yeah? So I will come out here. This is 135. That is theta. But theta has made this reference angle here. Everybody understand? What? Oh, sorry, it wasn't 135. Harry, you said 120, right? Yeah. Okay. So the reference angle will live in there. How could I find it? Jordy. Right. This reference angle, quadrant 2 reference angles, are 180 minus theta. Why? Well, theta starts here. If it went all the way to there, it would be 180, but we only went 120. Everybody cool? Everybody's good? Okay, give me an angle that would be in the third quadrant. 190. Okay, so it will end somewhere down here. Will it end close to the x-axis or close to the y-axis? Very close to the x-axis, yes? I'm going to move it a little further so I can write in the space. Everybody okay with that? It's going to be out here, yeah? Theta is this. Correct? The reference angle is between the terminal angle and the nearest x-axis. So where is it? Is it above the line or below the line? Above. So there is my theta reference. In quadrant 3, how would you tell me what that is? $270 minus 190. Because we said this was, sorry, I want to write that in, 190 degrees. 190 degrees. 270 minus 190 is, what's 270 minus 190? 80. Is this distance 80? What is it? It's 10, isn't it? Because I only went 10 past 180. So, how do I use it? This is 190. This is 180. How do you use numbers like this to figure out this one? $270 minus theta. We just did that. 270 minus 190 is 80. That can't be right. We know it's 10. Theta minus 180. Theta minus 180. Everybody cool? And in the fourth quadrant, obviously, what are two shades I haven't used? Green, pink, and red. Green. They don't have any more shades. But I need another shade of orange. Orange and yellow will do. So there's my initial arm. Give me one that will be in the fourth quadrant. 330. So it'll be down here, yeah? Will the reference angle be the blue dot or the purple dot? Purple dot. They look almost the same, I bet, on the screen. Yeah. So here is theta, and we said theta was what? 330, right? And then theta reference is in here, theta r. How will we find theta r doing something like this? In quadrant 4, it is 360 minus theta. Is everybody good? Try it. Do those 4. Go. Why is the first one super easy? You can do it in 1 second. What? Stays the same. It's 15 and 15, isn't it? What color haven't I used in a long time? You're right. Is that a good representation of 15 degrees? No. Is that better? Yes. So the theta r is 15. All right. What's B? There's the angle, 120. Theta r is 60, right in there. 250. Theta, 250. What's theta r? 70. Yeah? Okay. And lastly, 350. 350, and theta r equals 10. Is everybody good? Now, the question on your minds, hopefully on some of your minds, is why do we care what the reference angle is? I hope somebody asked that in their heads. Did anybody? Damn. All right. Can I do trigonometry with that purple triangle? Right now, as it's drawn, without adding anything to it. What's missing from that purple triangle? A 90-degree angle, yes? What does that red triangle have? A 90-degree angle. So could I do trig now? Yes. That's why reference angles are important. Everybody cool? All right, turn the page over. And now all I want you to do is take your knowledge of x and y coordinates, your knowledge of angles, and draw. That's step one. Step one, draw the terminal arms. Step two, give the measurements. What do you mean, Mr. Myers? Allow me to show you. 3, 2 is going to be where? First quadrant. 3, 2. Agreed? There's the angle, yes? Give me the measurements. How far is this? Oh, I drew that really badly. How far is this? How far is this? How far is this? What's 3 squared? What's 2 squared? What's 3? 9 and 4. Why am I hearing more than one answer? 9 plus 4. Somebody said 12. Somebody said 15. I don't care. Go. What is 9 plus 4? 13. So this is square root 13. That is what I want to see for these 8. Go. When you finish that, I will show you the right answers, and then you will do page 274. On your page 274, ladies and gentlemen, is there a number 8 down here? No? Good. Never mind then. Carry on. Are you ready to see these yet? Are you ready to see the answers yet? Okay. There you go. Everybody should have been able to do these.
Do we have to square root them? Like, so it says
No.
you're just writing root 20. You don't have to?
I don't. I wanted it done in like 10 seconds. I mean, of course, you know what to do in math class with square root of 20. That's the square root of 4 times 5, which is 2 root 5. Right? We all remember that from our very first unit of roots and powers. I know you do, because you got a final coming up in 5 days or 8 days, so you all know that the square root of 20 is 2 root 5. You know that it is not at all 4 point blah, 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 which is what you all want to do when you see root 20. Right? But it's not that, because it's 2 root 5. All right. Once again, you are working on page 274. Listen to me, please. Monday is test day on measurement, which means what day will we be revisiting 274? Tuesday.